Okay, we're on. Hold on, let me get the movie going. Um, there we go. Now you can see my ugly mug. Um, and we've already met because we had class on Tuesday. This is for your Thursday um, uh, class to have, so you can have a little video thing, and there will be some questions over, just just 3 or 4 real easy questions, um, because what I'm hoping to do in this afternoon's class that we haven't met yet, but I'm kind of predicting the future here, is to do the trig. Is to jump into the trig thing with both feet, and we'll kind of cover the what physics is and what SI units are, which you all probably already know, in these little videos. And so welcome aboard again to Physics 210. This is a whole new way I'm doing the class, and it'll have some fits and starts at the beginning, but I think we'll work it out. And the whole idea behind what I'm doing, and I've probably said this will probably be about the 15th time you've heard this. The whole idea behind what I'm doing is so we have active learning in the lecture. I mean, you're there for 75 minutes, and you should be engaging with one another and wrestling with the concepts and the problems, and being active. And I'm going to post these notes or these slides on Blackboard so that you have access to them, and you don't need to really take the notes. So without further ado, let's get into what physics is, and to what and to what SI units are, and then then the second part, and it'll take about 6 or 7 minutes, and then the second part, when we get into the units, I'm going to show you this very cool. It's about an 11-minute video from the Versatium library of videos, and I met this guy at a physics teachers conference, and he's very interesting. He's very engaging, and I think you'll enjoy it. So, without further ado, let me go ahead and knock this off. All right. So, what is physics? Basically, I know what the slide says, but basically, physics is the study of we observe nature and we take a measurement and we put a number on it. Okay, that's what we do. Kind of like the I don't know what that was all about, but anyway, um, kind of like Beyonce and single ladies, put a ring on it. In physics, you got to put a number on it. Otherwise, you haven't done physics yet. You're making predictions, and we put a number on. Now, where we get into problems, this is where Einstein got upset with quantum mechanics. Is we make a uh, prediction based on probabilities. And that's where Einstein says, wait a minute, God doesn't throw dice. But for our purposes, we look at, in physics, we look at the physical world, and we even look at the biological world and what's going on with the protons, electrons, and muscles and forces that are taking place inside the biosphere also. So it covers, physics is everywhere. All right. That's one reason I like teaching it. But anyway, um, so we can move on here. There we go. All right. Physics predicts how nature will behave in one situation based on the results of experimental data from another. All right. Like Newton's laws gives us rocketry, Maxwell's equations. Maxwell, we'll look at him in chapter 2, or in the second semester. All right. Follow the measurement, variety of quantities. So we have to have the units. We all have to be talking about the same units, because if I said, for this to be accurate, if I said, hey, if you ask, well, how far is it to your house from the university? And I said, oh, it's 1.3 gigacentimeters. You'd be like, what? Does that make any sense to you at all? You know how many centimeters it is from my house, from the university to my house? Or if I said it's a hop, skip, and a jump, that doesn't help. It kind of does colloquially. It kind of means, well, it's not that far, but I've got to get a more exact measurement than that. And if I said, oh, it's 30 kilometers, Well, someone, our fellow students that are international students that are among us, and there's a lot of them in this class, will be like, they know exactly. Americans, on the other hand, be like, well, exactly how far is that again? Divide it in half and add 10%, basically. Cut it in half, 30 kilometers, cut it in half. That's 5, that's 15. 30 divided by 2 is 15, and add 10% of the 30 is 18. It's 18 miles. Right? Now we're talking the same units. So to do science, we have to be in the same units. This is where me and the chemistry folks, we kind of part ways a little bit, because they like using, because they're using small things. You guys measure a lot of things in cc's and grams. Physics is manly. We do kilograms and we do cubic meters and things like that. But our SI units are meters is the unit of length that we use, kilograms is the unit of mass, seconds is the unit of time, and there's the actual meter. That's the old measurement of a meter. Here's the old kilogram. I'm going to show you some new things on the kilogram. They don't go into how these things, and you got to be very, very careful about what do you mean by a meter. Now this is in the archives, but actually what they've decided a meter is, here's what they've decided a meter is. Because it is based upon, and I'm going to show you this thing in Versatium, because a meter is based upon 1 meter, according to the systems and measures, is how far light travels because we know the cosmic speed bump of light. Cosmic speed bump of light. Light is basically equal to the speed of light. C is basically like 2.99 times 10 to the 8 meters per second. So a meter is how far light travels in 1 over 10 to the 0.99 times 10 to the 8th seconds. Okay? 1 over that. You take this unit of time, which is really dinky. Let me show it to you on my calculator. If I can find my calculator. Here it is. If I show it to you on my calculator, we'll look at, it's 1 divided by 2.99 second e to the 8th. Okay, that's our second. 3.344 times 10 to the negative 9 seconds. How far light travels in that amount of time is a meter. And the guy in Versatium will explain why we want to use other things besides physical quantities, because this thing will change. This is a constant. What I'm showing you here is a constant. Whoops, hit the wrong button. Sorry. What I'm showing you here is a constant that doesn't change. What happened to my ladybug? You better show up. This is a constant that doesn't change. All right. So you got the gist of it. Whoops. Length, meter, the CGS system, which is you use the CGS system a lot in chemistry, because you're using centimeters and grams, because you use smaller things. And then the British thing. All right. Units for length, mass, and time, as well as a few others, are regarded as base SI units. There's a few others, like the amp, that doesn't involve some of the others. These are used in combination to define additional units for other important physical quantities. And then here's some basic conversions of units. And I expect you all to be able to do conversions of units. I mean, that's something you did in 8th grade science. Okay? You should be able to do those. And if you ever get stuck, let me show you. If you ever get stuck with the, yes, I was playing around in that. If you ever get stuck with conversions, Google. Google is your friend. Okay? All right. I'm going to go ahead and stop this recording now, and then I'm going to show you the Versatium. Then video 2 will be the Versatium thing on the kilogram, and then video 3 will be a wrap up. And it shouldn't be more than 25 minutes of your time.